Hi, hello viewers. Alright, welcome to today's episode. Okay, on the board here we have some equations on the board, some chemical equations on the board. Now, what are we asked to do with these chemical equations? We are asked to identify whether each of these reactions has a negative entropy change or a positive entropy change. Now, before we start analyzing the entropy change of these chemical reactions, we have to ask ourselves, what do we mean by entropy change or the word entropy? The word or the term entropy simply means the degree of disorderliness of a system. So when a system is more disordered or more scattered, it has a higher entropy. When a system has less disorderliness, it has a low entropy. Now, entropy change means moving from a more arranged to a less arranged system. So if a system is more scattered and then it moves to more orderly, then it has a negative entropy change. But when a system is less scattered or less disordered and then it moves to a more disordered system, it has a positive entropy change. Now, the first equation here on the board is sodium chloride and sodium chloride. How do we tell? Now, if you look at this, you find out that the state of this sodium chloride is solid, while this is what is in an aqueous state. Now, what does this simply mean? Solid states are more ordered, they have less entropy. But when this particular sodium chloride is dissolved in water, it is now in an aqueous state, which means it is more in a disordered manner. So from less disordered to more disordered, that is more scattered, it means that the entropy change is positive. It has more entropy change. So from solid to aqueous state, the entropy change here is what is positive. Now, how about chlorine gas and chlorine gas? Now, in this case, gases, we know they have more entropy, or their entropy is more scattered, right? The system is more disordered. But how do we now tell if it's a negative or a positive change? Now, if you look at this, we have just one molecule of this chlorine gas, and on the other hand, we have two molecules of this chlorine gas. How do we now tell? We can tell that by saying that one disorderliness gives us two disorderliness, meaning two scattered system. So mean that this is more scattered than this. Right? So from one gaseous state to two molecules of gaseous state, it means that the entropy is positive. We have more disorderliness in this system. Now, what about this? In this reactant, we have nitrogen